You know, they're right, actually. We don't have a working model for how this record gets built up.
About 19:20 last night, that's 7:20 in the evening, we started tracking this iceberg about the size of a very large building, and it seemed to be interested in us. And if we look at the plot, we can see that during the evening and early morning hours that it's come directly at us. If we look over here at the expanded scale, we see now that it's at 9 o'clock. We were a little over 3.5 miles from us. We've had a lot of experience with ice. This is the first one where we actually had to deploy the free fall funnel and get out of Dodge. So the decision is made, bring the pipe home as safely as we can.
So on all cruises, there's a tension between the amount of time that's been allocated to the ship and the scientific objectives. And often you have a number of different research groups, and those objectives, those sites will be complementary, but sometimes they're also competing as well.
This is the forecast I normally use, and I look at
this particular expedition is kind of even more complicated because of the place where we are. We've got variable ice conditions, icebergs and sea ice. There's also, you know, the very variable weather conditions. It can turn stormy very quickly in the Southern Ocean.
It was known that the weather was going to be a problem, so we made special arrangements, and we got ourselves an experienced weather forecaster, Shell Beckfall, who has been out here 2 other expeditions.
Okay, John, we're up and running, so you're okay.
And then we also brought aboard an ice observer who was an experience in both the Arctic and Antarctic conditions, and that was Diego Mello. Those 2 guys presented a formidable team and really assisted us in helping to be such a great success.
Quite a few of grounded bergs as well, what we call fast ice, ice that's attached to the shore.
We don't have a crystal ball for predicting what's going to happen in the future. We do have a tape recorder of how the climate has changed in the past, and that's reflected in the ocean sediments of the world.
We use these climate models as a first stage prediction, and what we find in sediment drill cores on the Wilkes Land expedition helps feed back into these models and refine them. So, for example, the microfossil assemblages that we find and the lithological sequences feed back into climate models to make better predictions.
No matter how good the models are, they're always a simplification of the real world. Whereas with the IODP, we can go back and make these measurements through time, through continuous undisturbed sequences that are not available on land. We can only get them from the oceans. And we're looking at the real world. We're looking at real history.
Quite interesting is that we get from the super greenhouse world, we are getting values that they cannot reach with the models. And that points to a significant sort of gap in the knowledge of the physical atmosphere characteristics or things like that, where the data now show, I mean, you know, crocodiles don't lie. I mean, it means that it was freaking warm. And they, whatever they do, even if they raise CO2 values through the roof, they cannot come up with those kinds of temperatures. And that means that there must be more interaction between the data folks and the model folks. And that's precisely why we're here. We are getting this solid data from the field. They then can use that into their models and to go into a new mode of better understanding not only past climate changes but also future.
Well, we're trying to take the first core, and unfortunately when the core barrel came back, only the upper half was left and recovered. So we lost the lower part of the core barrel.
This is ocean drilling. This is what you get.
Mother Nature is in charge.
Mother Nature.
Mother Nature is in charge.
So no wrong decisions, just decisions. The planning of every expedition has its own unique set of challenges, whether it's weather, it's ice, it's remoteness, it's difficult coring conditions. We managed to wrap all those up in this particular expedition.
Good morning, final core. Let's go home. We've got a lot of research planning to get the scientists all going on the post-cruise research. We're focused on the future. Now we're going to take these cores and start seeing what secrets they have that tell us about the history of glaciers on Antarctica.
And then the final success will be really measured in the coming years, maybe even a decade as we publish our scientific papers. So it's our duty to do the work, to produce the data, but really we have to publish the papers. And then if the climate change story from those papers is important, then that has to go beyond just the scientific literature. It has to be communicated to the public and to policymakers.
So as said, when it was up to me, then all of our 1,000-page thick report would actually look like these two sheets here, these two cartoons, which basically portray both the large-scale tectonic evolution of the ever-widening space, basically, between Antarctica and Australia. The other thing is that the climate has been changing from this greenhouse world here into the icehouse, and that this icehouse is getting stronger and stronger. And that at the same time, this basin actually developed also partly in a consequence of the enormous power of the erosion that comes from the ice sheets and dumping all of this clay and silt and coarse gravel. And so basically, if you want to know what is the summary of this expedition, this is it.
And this is an international program. And there's people from all over the world joining together for one common goal. They're out here for 2 months, they're living together, they're working in the labs together, and they're trying to answer unknown questions.
Actually, it's one of the best things in the JOIDES, that you have to have 2 months with these people that you did not know before. And since you have no place to go, you have to meet with these people and talk to these people, and you share experiences that you would not have shared otherwise.
We have chicken, the classic hamburgers, pork spare ribs, sausage, corn on the cob, and a nice table with sweets and salads.
Where else in the world can you have a barbecue and look at icebergs at the same time? You just have to eat fast. Your food gets cold real quick. This is one of the best iceburgers I have ever tasted.
You really get to know people well. I mean, after a month or two, you know someone as well as if you'd known them for 10 years. You find out all about their family, their hobbies, what they're interested in. And you build up some really, really strong bonds.
Next up, Hobart, Tasmania.
We are in Hobart, and we did it. We did it.
No more ice. Everything without ice from now on.
I miss my family, really.
Good. Thirsty.
You know, mixed emotions about leaving the boat, but I'm looking forward to having the first nice cold beer in 2 months.
A little bit of flies in the stomach.
Everywhere I go, there I am without you. Every single night another dream about you, but I'm coming home.
Well, I must say, there are some horror stories out there, but this cruise was really a very well-functioning orchestra. Plus, we have a good mix of sort of youngsters who are learning, and they can learn from the older people. Everything was fine.
Wish that I could take you everywhere I go and bask all day in your ever-loving glow. So I'm coming home. Yeah, I'm coming home.
I think it's a very different experience once you've actually been there on this ship, gathering these cores, sailing out there, preparing for everything. It's a whole different game.